It is incredibly satisfying to watch a 3D printer lay down plastic to form a physical object you created. But for a lot of people, the process stops before it even starts, because learning traditional computer-aided design software can feel like trying to read a foreign language backward. That is where Tinkercad comes in. It's a completely free platform created by Autodesk that simplifies the entry point and gets you building immediately. There's no heavy software to install or hardware requirements to worry about. As long as you have a modern web browser and a working internet connection, you are ready to go. In the next 6 minutes, we are going to start with a blank screen and finish with a digital file that is completely prepped and ready to send to a 3D printer. By clearing away the software barriers, you can focus entirely on the practical process, taking a digital idea from your browser and turning it into a physical object. Step 1 is simple. Go to Tinkercad Online and set up a free account. You can choose a personal account or an educational one if you're a student or a teacher. Once you log in, you will land on your main dashboard. You'll notice the platform is divided into a few distinct modules, catering to different kinds of projects. This interface mockup shows exactly what we are looking for. Click on the 3D Design tab and then hit the New Design button to launch your project. The screen will transition to your main workspace. Right in the center, you'll see a large blue grid called the work plane. Think of this as your virtual desk. Before doing anything else, look to the top left corner. Tinkercad gives every new file a random auto-generated name. Change it immediately to something logical so you can actually find your project later. From this point on, every change you make is automatically saved to the cloud. There is no manual save button to click, and no risk of losing your progress if your computer crashes. This automatic backup removes the fear of data loss, allowing you to focus on the actual design process. This diagram illustrates the core mechanism of the platform. Over on the right side, you have a menu of predefined basic shapes. To build, you just select a shape and pull it directly onto the central work plane. When you click on your shape, notice the small black and white handles that appear around its perimeter. These are your manipulation tools. By clicking and dragging these exact handles, you can stretch the object to change its scale, spin it to adjust its rotation, or move its absolute position on the grid. Bring in a second shape, intersect them, and you start building out a unified structure. This is a process called rapid prototyping. You are taking simple geometric blocks, combining them, and testing out different iterations of your idea in real time. If you stretch a block too far or rotate it the wrong way, just use the undo function at the top of the screen to step back. Mistakes cost nothing here. As you get started, always stick to assembling these foundational shapes. This is how you build the skills to eventually attempt more complex models. When you stop viewing 3D design as a set of complex coordinates and start seeing it as an assembly of basic shapes, you have already cleared the biggest mental hurdle to building your own models. Finishing your digital model on the screen is only half the job. To make it real, we have to extract this data into a format a machine can manufacture. This interface mockup highlights the final step. Go to the top toolbar and click the Export button. A menu will appear. Select .stl. This is the universal file type required to communicate your three-dimensional geometry to standard 3D printers. After exporting, open your computer's local downloads folder. Verify that the file is sitting there, successfully transferred from the cloud. Generating that single standardized file is what bridges the gap. You have successfully crossed over from digital ideation to physical manufacturing. In under 6 minutes, you went from an empty browser window to possessing a tangible, production-ready digital asset. The rapid prototyping skills you just used to place a basic cube or cylinder are the exact same mechanics you'll use for more advanced projects as your ideas grow. And the 3D design workspace is just one module. Tinkercad also features dedicated environments for simulating Arduino electronic circuits and writing visual code blocks. This workflow, moving from basic shapes to a finished file, is the same one used whether you're building a simple household gadget or your first robot component.